Most bad RAG systems are not failing because the model is dumb. They are failing because the search stack is asking the wrong question, then grading the wrong answers.
Exactly. And the confusion usually starts here. People mix up the embedding model and the reranker, as if they do the same job.
So draw the line fast. If I am building retrieval, what does the embedding model actually do?
The embedding model turns text into vectors, so similar meaning lands near similar meaning. Its job is broad recall. It helps you find a candidate set that might contain the answer.
And the reranker?
The reranker looks at the query and each candidate together, then scores which chunks are actually most relevant for this exact question. Its job is precision, not coverage.
So, one model is casting the net, and the other is sorting the catch.
Right. Practical example. A user asks, can European customers export audit logs from the admin panel? The embedding model might retrieve docs about audit logs, admin settings, compliance, and data export. The reranker then pushes the chunk that specifically mentions export availability for EU accounts to the top.
That sounds clean, but teams still act like one stronger model will fix everything.
Because both stages affect the final answer, but in different ways. If the embedding model never retrieves the right chunk, the reranker cannot magically rank what it never sees.
So if recall is broken, precision is irrelevant.
Yes, and the reverse is also true. If retrieval brings back 20 vaguely related chunks, a weak reranker may put a shiny but wrong chunk at number 1. Then your generator answers confidently from bad evidence.
That is the dangerous failure mode, right? Not no answer, the wrong answer that looks grounded.
Exactly. In production, that changes who wins. The team with slightly better retrieval, but much better re-ranking, often beats the team with a giant index full of loosely relevant text.
Give me a case where improving embeddings does not solve the problem, even if recall gets better.
Suppose your docs contain 2 near-identical chunks. One says a feature was deprecated last year. Another says it is available, but that page is old. Better embeddings may retrieve both, but they will not reliably decide which one best answers the query. That is a ranking problem, not a retrieval problem.
So more semantic reach can actually increase ambiguity.
Yes, you can retrieve a larger pile of plausible text and still ship worse answers if the re-ranker is weak. More candidates are only useful if the top of the list gets smarter.
Now, flip it. When does improving re-ranking fail to save you?
When the candidate pool is missing the target. Imagine a support bot for an internal API. The query is, why do signed upload URLs expire after 15 minutes? If your embeddings miss the one design note that explains the security window, the re-ranker can only choose among partial distractions like token refresh docs or storage limits.
So, the re-ranker becomes a judge in a trial where the key witness never showed up.
Perfect analogy. It can make the best bad choice, but it cannot invent evidence. That is why tuning re-ranking on top of weak retrieval often creates the illusion of progress. Top results look cleaner, but answer quality plateaus.
This is where teams lose months, right? They stare at generation prompts because the output sounds wrong, when the real issue is upstream.
Yes, a fast way to think about it is, embeddings answer, what should enter the room? Re-rankers answer, who should speak first? If the wrong people enter, order does not save you. If the right people enter, but the loudest fool speaks first, order is everything.
That also changes evaluation. You cannot just measure final answer accuracy and hope to know what failed.
Exactly. You need to inspect retrieval recall separately from ranking quality. Example, for the query, does deleting a workspace remove billing history? If the correct chunk is absent from the top 50, work on embeddings or chunking. If it is in the top 50, but buried at 37, work on re-ranking.
That is the practical split programmers need, not architecture theater. Just isolate the failure mode.
And there is a strategic consequence. If you only optimize embeddings, you bias toward broad matching and may flood the context window with decoys. If you only optimize re-ranking, you create a polished bottleneck sitting on top of blind retrieval.
So the power shift is simple. Retrieval decides what is possible. Re-ranking decides what is probable.
Yes, and in RAG, possible and probable are not the same thing. Great embeddings widen the search space. Great re-ranking sharpens the decision. You need both, because missing truth and misordering truth are two different bugs.
Which means, when a RAG system lies, the fix is not get a better model, the fix is figure out whether you failed to find the evidence or failed to recognize it.
Exactly. In retrieval, the winner is not the system that knows the most, it is the system that brings back the right evidence, then has the judgment to put it first.